So this question is going to come up in some form or another on your paper 2 because they like this question and it's a big part of the course. So this is the acceleration, how the force affects acceleration. Okay, F equals ma, Newton's second law, all of that stuff. And the way they've done it in this paper is they've asked you it as a series of questions based around the practical. But they could do this as a 6 marker, like how would you do this? They could have it on a slope, they could have it going through light gates, all of those things. You've seen all the variations really, but this is how they've done it here. So let's go through this one. So as a student investigated how the acceleration of a trolley varies with the resultant force on the trolley. Figure 10 shows some of the equipment used. So there's our trolley, there's our force pulling it over the pulley. Well, there's the mass hanger, which is providing the force. There's a string, there's a bench, there's a runway. So figure 10 shows the force F, which acts on the string or through the string. What name is given to the force? And that force is called tension because it's a pulling force. When you were 7, you'd have called it pulling. Now that you're doing GCSE and you're as smart as you can be, then you're going to call it tension. There's other contact forces like compression, the opposite of tension. So you get compression in a spring and you'll get friction. All of those are contact forces, but this one is tension. So learn those basic contact forces. Remember the non-contact forces as well. They don't come up here, but they come up quite regularly. So you've got magnetism, you've got electrostatic, and you've got gravitational. There you go, remember those. 5.2, give one variable that should have been a control variable in this investigation. In other words, one thing you kept the same. And to prove that you're higher tier students, you need to remember that the total moving mass, i.e. the trolley and the mass hanger, is kept the same. And if you look over on the right hand side here, you'll see that that is given there. The mass of the trolley and mass hanger is kept the same. Sometimes they might change the mass and see how that affects it. That's an inversely proportional relationship, but we'll come back to that some other time. You can ask me about that in lessons. So 5.3, student held the trolley stationary. So that immediately tells me that the speed at the start, the U speed, the U velocity is 0, and then released it. The trolley moved along the runway with a constant acceleration. The student recorded the time t taken for the trolley to travel a measured distance s along the runway. So I put all these in. This is my normal way of doing things. I would follow the same pattern if I were you. Describe 3 marks, got to do a bit of a description, how the acceleration of the trolley can be calculated using the time taken and the distance travelled by the trolley. So we've got time, we've got distance, and we want to find acceleration. So this is a question where most people get 2 marks, and I'll tell you why. The first thing you've got to say is find the average acceleration using velocity is distance divided by time. Okay, we've got distance and time. That's what we're doing, what we're given. But then, having found the average velocity, you've got to realise that the average velocity is made up of the initial plus the final divided by 2. So that average velocity, which you'll find on the equation sheet, is one we don't use very much, but it's one you needed to remember that what you found there was the average velocity because it's accelerating. So it starts at 0, gets to a final velocity v, and the average between u and v is going to be u plus v divided by 2. So in order to get the final velocity or the maximum velocity, you have to double that average velocity because you halved it to get the average in the first place. Just take a few moments to think about what that is, what I've been talking about, because that is the bit most people miss out. Once you've got that maximum velocity, you found v. Okay, so then you can use that maximum velocity v minus initial velocity, which was 0, so that's easy, and then divide it by the time taken, which you've also recorded. So it's basically v divided by t. It's the change in velocity divided by t, but that's 0, therefore it's v over t. So there's a little bit to think about there. If you look over on the right hand side of the mark scheme again, you've got all of that written here. Ignore the s equals ut plus half at squared. That's another SUVAT equation we don't usually introduce to A level. You don't need to know it for GCSE. They just put it there in case some schools have taught them early and they've used that. We're always going to allow correct physics used in an exam. So if a student had used that and used it correctly, they'd have got the marks. Right, the next bit. For one set of results, the force acting through the string was 2 newtons. The The student released the trolley 3 times and determined the following values for acceleration, that, and that. Calculate the uncertainty. Okay, so the uncertainty is half the range. So range over 2. The range is the difference between the highest and lowest values. So 1.39 minus 1.33. Then you divide it by 2, you get 0.03. So our uncertainty is plus or minus 0.03. So remember that equation, the uncertainty is range over 2. They will ask you uncertainty at some point in the paper, so make sure you've learnt that. All right, 5.5 looks a bit complicated because I've made it more complicated than it needs to be, but don't worry about that. Just follow along the basics. It says the runway was then raised at one end. Aha, so that's about compensating for friction, or is it? Or is it because we're going to change the height? We'll see in a minute. The force of acting through the string remained the same. So figure 11 shows this, so ignore all the red and mathsy stuff for now. Explain how the acceleration was affected by raising the end of the runway. Okay, so basically, if you raise the end of the runway, there's going to be a greater gravitational effect on this trolley now because it's going to have a component of that weight going down the trolley. So what I've done here is I've done the maths of that. So if you take a moment or pause the video and look at what I've done, I basically use SOHCAHTOA or whatever you call it nowadays to work out the fact that there's a component of the force acting down the slopes, because that's the weight of the trolley. Okay, there you can split that into 2 components, one at right angle to the trolley and one going down the trolley, and then you've got this bit of force going down the trolley which happens to be W sine theta, but you don't have to worry about that too much. That's more of an A-level thing. But basically, this is the answer you want to give. This component of weight acts parallel to the runway, therefore the resultant force is increased, and therefore the acceleration is increased. So you've got basically more force going down the runway. You've not just got the mass hanger, which has stayed the same. That's creating force because of the gravitational pull on that mass there. But you've also got an extra bit of force because of the gravitational pull down the slope, because it's a component of this weight here. A little bit more complicated, but have a look at the answer. Look over on the right hand side of what you were supposed to give. If you want a moment of maths madness, look at what I did here, because that will help you with your maths as well and resolving forces. But that's that. I'll do another question in a bit.